Understand the initial conditions of the vessels. At 27 degrees Celsius, both vessel 1 and vessel 2 are filled with the exact same volume of inert N2, 2.0 liters, at the exact same initial pressure, 720 millimeters Hg. Additionally, vessel 1 contains 0.050 moles of solid sodium bicarbonate, NaHCO3, and vessel 2 contains 0.050 moles of solid sodium bromide, NaBr. Account for the temperature change. When both vessels are heated from 27 degrees Celsius, 300 Kelvin, to 127 degrees Celsius, 400 Kelvin, the average kinetic energy of the gas molecules increases. According to Gay-Lussac's law, P is proportional to T when volume and moles of gas are constant. This temperature increase causes the pressure of the N2 in both vessels to rise proportionally to approximately 960 millimeters Hg. Analyze the chemical behavior of the solid in vessel 2. Vessel 2 contains sodium bromide, NaBr, which is a highly stable ionic salt with an extremely high melting point. It does not decompose, melt, or vaporize at 127 degrees Celsius. Therefore, the number of moles of gas, N, in vessel 2 remains completely constant, and the pressure inside is due solely to the heated N2. Relate the pressure difference to the number of gas molecules. The problem states that at 127 degrees Celsius, the pressure in vessel 1 is higher than that in vessel 2. According to the ideal gas law, PV equals nRT, because volume, V, and temperature, T, are identical in both rigid containers. The higher pressure in vessel 1 can only be explained by a larger number of moles of gas, N, in the container. Evaluate the decomposition of sodium bicarbonate. Heating sodium bicarbonate, NaHCO3, causes it to undergo thermal decomposition. The balanced chemical equation in option C shows that solid sodium bicarbonate decomposes to form a solid carbonate and two gaseous products, water vapor and carbon dioxide gas. 2 NaHCO3 gives Na2CO3 plus H2O plus CO. 2. The generation of these extra gas molecules increases the total moles of gas, N, in vessel 1, resulting in a higher measured pressure compared to vessel 2. The correct answer is option C. 2NaHCO3 gives Na2CO3 plus H2O plus CO2.